This week we're going to continue sorting shapes, and it's probably the last lesson for sorting shapes. Um, and it takes the previous two lessons and really kind of smashes them together into classifying shapes. And I don't really think it's that hard. So the first thing we're going to do is we're going to classify or sort shapes by angle measure. Okay, so here are three triangles from the previous lesson, right? And I can look at these triangles just by looking at classifying their angles. So this triangle here has all acute angles. Okay, angle BAC is acute, or we could just say angle C here, angle B, and angle A, all acute angles. This triangle here, okay, is called a right triangle because it has a 90-degree corner right here. Okay, so angle E is 90 degrees. The final triangle is an obtuse triangle, okay, because it has an obtuse angle right here. Angle H is obtuse, right? And you can look at this angle and you can see for yourself that it's definitely more than 90 degrees. So an obtuse triangle has one angle greater than 90 degrees. Okay? Now, you have to remember that it's impossible to draw a triangle without acute angles, right? So you can't say, well, this one has acute angles, so why isn't it an acute triangle? You're basically just looking at this corner right here, right? Or same with this one. Why is this a 90-degree triangle or a right triangle if it has acute angles? You can't draw a triangle without acute angles, right? So you're basically just looking at one corner for these two. Okay, so we're going to move on, and we're going to look at some quadrilaterals. Okay, so once again, I pre-drawn these quadrilaterals to save some time, and we're still sorting them by angles, right? So the first one is a rectangle, and a rectangle has four right angles. Okay, so if we classify it by angles, we could say that this is a 90-degree corner. Okay, that's a 90-degree corner. Here's a 90-degree corner, and here's a 90-degree corner, right? All of them are 90 degrees, and I'll even prove it to you in a second. The next one, this shape here, is a parallelogram, and it has two pairs of equal angles. So I'm going to write that down so that you can see it. Okay, so I'll name it first. Okay, so you remember parallelogram from the previous week. Two pairs of equal angles. And done. We'll lock it in place. Now, before we move on, I want to measure some of these angles just to prove it to you. So this is the protractor tool. I know it looks a little bit strange. So the first one is, okay, this one here is it's a rectangle, has four right angles. That means that it should have 90-degree corners, right? So if you look here, oops, it was 90 degrees. Okay, I just made the thing disappear, so I'll put it back. You can see. I can't use the pointer at the same time. So 90-degree corners, right? So angle K is 90 degrees. Now, this shape here is a little bit more interesting. Okay, so if I move the protractor here, okay, and I do one of these, okay. Now, again, I can't use the pointer, but you could see that angle NQP, or angle Q, is 112 degrees. Now, it has two pairs of equal angles, and those equal angles are across from each other, and I'll show you. So this is 112. I won't even have to move the protractor if I do this right. Let's not make a mistake. So see, now angle Q was 112 degrees, and so is angle O, right? And I can do the other two as well. Now I can tell you right now that there, it's done already. See, so angle N is 68 degrees, right? And then if I do flip it around again, hopefully it lines up right. It doesn't look like it's going to line up correctly. Oh, it did. So angle P is 68 degrees, right? So basically, what that proves is that this was 112 degrees, and so was this one. Okay, this one was 68 degrees, and so is that one. Okay, now the last thing we're going to do, we're going to move on. We're going to look at, you can sort sides, or sort polygons, whether they are regular or irregular, right? So I'm going to draw some regular shapes, regular, right? So here we go. Okay, I don't like the way that turned out. Can I move it? There. Okay. Now, you may remember that, I'll lock this thing in place or no? Okay. You may remember from a previous lesson that this is an equilateral triangle because all the angles are equal and all the sides are equal. So these little ticks here mean that the sides are equal and all the angles are equal. Okay. I can measure it to prove it. Okay, so see that the angle R is 60 degrees. And I could pretty much, or I'll just do one more. You're gonna have to take my word for the third one to save some time. But angle S is also 60 degrees. So all of the corners are 60 degrees, 60 degrees, 60 degrees, and 60 degrees. So this is a regular polygon because it has all sides that and all angles equal, okay? And that's really what a regular polygon is. So I'm gonna do my note. So a regular all sides and angles, I'll even put the word all again, all sides and all angles are equal. Done. Okay, so that's a regular polygon. Now, that's not the only one you can make, right? So I can do like a square. Okay, a square is a regular polygon. Whoa, that went, I didn't expect it to go there. Let's try that again. There we go. So a square. Now, no matter how big a square is, all the sides are equal. So for this square, we know that the grid tells you how many centimeters something is. So this is 4 centimeters. That's 4 centimeters, right? I'm not going to take the protractor out, but you could take my word for it. That's 90 degrees. But you should know a square has 90-degree corners, right? So this is a regular polygon because all the sides and angles are equal. We can draw more regular polygons. So the next regular polygon would be, here they are. So let's do a regular polygon. Okay, let's see here. One. Okay, so this tool here, it decreases in size, right? So here's the first regular polygon. Okay, it looks like we ran out of alphabet. Now it's going D1, H1. Okay, don't worry about that. Okay, so, whoops. Okay, I'm trying to move it so that it looks better, or it's on a line at least. Okay, well, it doesn't really matter. So for this polygon, all the angles and all the, okay, let's try that again. Okay, so the angles are 83 degrees, it says there. Okay, but all the angles are 83 degrees, right? And all the sides are equal, right? Now I can decrease the number and I could say, okay, so that was a pentagon. Okay, now here's a hexagon. So a hexagon is the same thing. It has all the angles that are the same, right? So all these angles are the same. Okay, all angles are the same. And all sides are equal, right? So this is a regular polygon, right? And basically when it increases in size, all all those shapes, like a square was four-sided shape, a pentagon's a five-sided shape, hexagon, and they keep going up. All those they're all regular polygons, right? Why? Because again, what we said here is that a regular polygon has all sides and angles that are equal. Okay, so if I go back to maybe just a simple pentagon, right? The pentagon is a regular polygon because all the sides are equal, okay, and all the angles are equal, right? And I can do the measure just to really push it with you. Hopefully this lines up correctly because, oh, that's good luck for me, right? So here's the pentagon. It's a bit off. Okay, and I think that's the best I could do though. So it was probably more like 108 degrees, but all the sides are the same, right? So if I go here, it's gonna be the same. Okay, and I can even move it. Remember, it was a little bit off there. So 109 degrees. So if I take this tool and I move it, okay, so it's 109 degrees. The protractor is not lining up perfectly. Maybe if I try over here. There. Oh, no. Okay, I just have to take my word for it. And if not, actually, I could probably just click on it and it could tell you, oops, that all the angles are, well, I could show the angle. There, so 108 degrees. Show angle, right? They're all 108 degrees. Okay. Now, if a regular polygon has all sides like this, so this equilateral triangle here is a regular polygon because it has all sides and angles are equal. This one here, same thing, all sides and angles are equal. The octagon, pentagon, everything you can think of, all those shapes that you've heard of, they all have equal sides and equal angles, so they're all regular. You're probably wondering, what's an irregular polygon? Well, an irregular polygon is basically anything else, right? So I can make, this is the last shape for this lesson. I can make an irregular polygon just by doing maybe something, oh, sorry. Okay, now this shape here is an irregular polygon because all of the sides, none of the sides are the same, and all the angles are different. So it's an irregular polygon. Okay, so I'll write the note. And there we go. Irregular polygon. Okay, so there we go. The difference between that's kind of the new thing here. So a regular polygon has all sides and angles that are equal. It includes all those shapes like the equilateral triangle, the square, not a rectangle, because a rectangle does not have all equal sides. All those shapes that increase in corners, so the pentagon, hexagon, octagon, you name it. And then the irregular polygon has no sides that are equal, equal sides or equal angles. Okay, thank you for listening.